Have you ever had a memory that was so traumatic and wanted to wipe from your mind? Kind of like the movie The Eternal Sunshine of the Spotless Mind. Well, what was once some crazy science fiction movie plot may be coming in the near future. This idea for the machine I'm going to explain has been shown to many neuroscientists and has been verified as possible, as well as a high probability to be done. We're currently trying to get a grant and an internship to build the machine and test the results. See, memories are stored in synapses and neurons in a neural network system that works in your brain. The memory erasing machine we're planning to build, combined with the recently built INU-MAC MRI machine, detects up to a scale of 1,000 neurons. The plan is to ionize these neurons to interrupt the memory. The theory here states you would not need to ionize all the neurons, but only 10 to 25%, because this should be enough to erase the memory or at least make it foggy to a person. Also, now there is a technique to detect whether or not a person possesses a specific memory. Stanford professor of psychology and neuroscience, Anthony Wagner, has come up with a technique using an fMRI machine and a computer algorithm detecting blood flow in the brain. The computer algorithm looks at this blood flow to determine whether or not it represents a memory or a novel experience. So, the fMRI machine scanned the brains of people looking at 2,000 photographs, and the algorithm studied the blood flow and tried to determine which ones represented memories versus new experiences. And this technique was right around 75 to 95% of the time. As you can see in the images from Jack Gallen's lab, they are very detailed. And the lab wasn't even using the INU-MAC MRI machine, which can image an area of about 0.1 millimeters or 1,000 neurons, and see changes occurring as fast as 1/10 of a second. So, combine these two neuroimaging techniques with the following experiment. A single neuron can contain around hundreds to thousands of synapses. So in 1,000 neurons, that is a lot of synapses containing the memories of specific spatial tasks. Imagine this is a cubic block of around 1,000 neurons below. This is an area in the brain the INU-MAC MRI machine can see activity happening in. As well as combining the latest and best CT scanners with magnetoencephalography and electroencephalogram to see the electro signals happening in real time. The blue line arrow above shows the gamma beam emit area. So you just ionize cubic areas of 2 to 25 microns within a cubic group of 1,000 neurons to erase the memory, each time moving on to a new cubic area after you have ionized a previous area. Then just keep asking the person to keep recollecting the same bad memory to see if it has been wiped. It would be a repeated process of ionizing cubic areas in the group of 1,000 neurons and asking the person if they can recollect the bad memory. It doesn't matter that we don't know how memories are consolidated, because you would accidentally find the groups of neurons that held these memories by a process of elimination. In this diagram, imagine the picture is a cubic area of 1,000 neurons. And the diagram is not to scale or realistic, it's just to give you an idea of the technique to erase the bad memories. Imagine the red circles are groups of neurons containing traumatic memories, and the green squares are cubic areas that the gamma knife has ionized. Remember, memories can be scattered all over the place in a block of 1,000 neurons or more. As you ionize more cubic areas in the block, you would ionize the groups of neurons that held the bad memory. Cubic areas ionized by gamma beams. Using the 10 to 25% theory means you wouldn't have to ionize all the neurons, just 10 to 25% should be enough to disrupt the memory. Memories are created when changes of a few molecules made in selected synapses disperse throughout many brain regions, and not in whole neurons, nor in sets of neurons located next to each other. Combine the INU-MAC with the latest CT scanners. With the latest CT scanners, the final picture is far more detailed than an X-ray image. Inside the CT scanner is an X-ray detector, which can see hundreds of different levels of density. Combine the INU-MAC and latest CT scanners with magnetoencephalography and electroencephalogram to see the electro signals happening in real time. Magnetoencephalography, the spin exchange relaxation-free magnometer, is being investigated for future machines. This will help increase the accuracy of the electro signal in the brain. Now you have both bold electro and chemical signals to deduce what neurons hold which specific spatial memory. Modify a gamma knife machine. Currently, the ball lens is needed to be worked on to ionize micron-sized groups of neurons in cubic areas in the brain. You could also combine two types of electromagnetic waves together as a single wave to ionize neurons better. Like combining X-rays with 10% of gamma waves, or whichever works best, but it all has to be tested to determine what works best, like in this diagram. Here is another diagram of how the modified gamma knife is going to work. With two modified gamma knife machines side by side, ionizing a cubic microscopic area in the brain. To locate the memory, you would ask the person to collect it, and it would be a repeated process on if they can remember it or not after the ionizing of the neurons. There is more that needs to be discussed on this process and the idea, which will be discussed in future videos. So go ahead and hit that subscribe button. You can now, however, check the link below for a full-on description on the project. We also have a Twitter and Facebook page that have been made. Our Twitter handle is @MemoryEraseLab, and the Facebook page is Human Memory Erasing Laboratory. Links to both will be in the description. Thank you for watching, and be on the lookout for more news.